Yeah, so here we are once again. Anybody have any announcements? Community announcements? Any events coming up? Meetups? No. All right. So next week we've got Patricia, who is going to come and talk to us about women in tech, the history, where we're at now, ways forward. So that's going to be a great talk. Come out and check that out. Other than that, we've got Adam Jimerson today coming to talk to us about PacBSD, and he works for Utiliflex as a systems architect. Give him a warm welcome, everybody.
Thank you, everybody. As Brett said, today's talk is about porting a Linux package manager to PacBSD. And so before we get in too much of the details, I'll take a minute to talk a little bit about myself. So I'm system architect at Utiliflex, where we write software for utilities to do prepaid electricity. We have several deployments throughout the Caribbean and a couple other countries worldwide. I am the lead community organizer for the local Google developer group, GDG Gig City here in town. We meet once a month, third Wednesday. Yeah. Okay, so I guess good thing I'm not going to be doing any typing. And I am also a PacBSD contributor and developer, website maintainer, and server administrator, and a bunch of other stuff. So you can reach out to me via email, or anything like that. I don't really do any social media, Twitter, or anything like that, so good luck. You can find me on Google Plus if you do use that. So some key takeaways for today's talk. Hopefully for those of you who have no idea what PacBSD is, maybe you'll come out with a little bit of information on what that is. Maybe you'll come out with some basic knowledge of Arch Linux's build system, as well as FreeBSD's ports tree and how they work. Some knowledge of the differences and similarities between Linux systems and BSD-based systems. And maybe a better appreciation for what package maintainers and managers do, regardless of if you use apt or yum or Homebrew or MacPorts or anything like that. And also for today's talk, you guys are a guinea pig for when I give this talk Tuesday in front of IX systems to a bunch of other BSD users and developers. So one disclaimer for this talk, some of you may not be too much aware of build systems, so some of this may not sound like English. I promise you it is, just hold on. Hopefully it'll make sense in the end. And kapla. Maybe I lied. So for those that don't know what PacBSD is, a quick summary. We are a free and open source computer operating system based on FreeBSD, which is a fork of the Berkeley software distribution developed by Berkeley University and a bunch of other people, as well as using the Pacman and the ArchBuild system for our package manager instead of using FreeBSD update and PKG or the ports for installing user software. We also offer users a choice between the FreeBSD init system and OpenRC. So we support 2 different ways of starting and managing services that users can choose at install time, or they can switch between during runtime as well. We also offer a choice between the BSD and the GNU core utilities. So commands like CP, MV, things like that. If you're more familiar with how they work on, say, OS X or other Unix systems, or if you're more familiar with how they work with Linux, you can install the appropriate ones, and we support both. We also use a hybrid between the ArchBuild system and porch trees when we're building our packages, and you'll see why we do so later on in the slides. And like Arch Linux, we are a rolling release, so we have no version numbers. It's just as a new version of upstream software gets available, we'll build it, and once it passes our automated testing, we'll push it to our stable repositories where end users can download it and install it. So why choose to be based on FreeBSD? Subjectively, there's better code quality and stability in the FreeBSD project because of how they maintain things. It's more of a singular project versus just a kernel and using other tools on top of it, as well as they're a little bit stricter about how things are updated and how things change. There's also native support for jails, which is a process isolation and containerization system that's more secure than chroot or Docker, and native support for ZFS without any kind of license or legal gray areas. As for why Pacman and the ArchBuild system, it's a fast and simple package manager that leverages single letter command flags instead of subcommands for things. So it's a little bit easier to remember, and it's also pretty fast at doing operations. It's also built from the ground up to be for a rolling release system, so it handles things a little bit better. And it also uses shell scripts instead of make files for how the to define how packages are built, which makes things a little bit cleaner and easier to read. So quick dive into what makes up the build system. It's made up of multiple repositories. The main ones are our testing, community, extra. You have community testing and multilib. Although the testing and community testing are really only used by developers, package maintainers, and the brave few that don't fear their packages just randomly breaking. And multilib is for people using a 64-bit operating system that needs to run 32-bit programs. So those have some people that'll use that, but not everybody. And then inside each repository, there'll be a directory for each package in it. So the Linux kernel is inside the core repository, and then you'll have packages like Xorg and Wayland and Firefox inside extra, and Adam inside community, things like that. And then there's requirements, so a package must include a PKG build file, which is the shell script that tells it how to compile the program and how to build the package. But it may also include any necessary patches needed to compile or to fix runtime problems. And then also a install file that has hooks that gets run after install or upgrade or remove, or transaction hooks for Pacman to run. And it also supports split packages. So one PKG build file can actually build 2 or more binary packages that can be installed. So quick dive through some of the tools. You have the make pkg command that parses the pkg build file. It builds the packages. It also assists with keeping up checksums current. So it's able to look at the files that's just downloaded and anything else that it knows that's a source, and it'll generate the checksum in a way that you can just pipe into the file itself. You have a ver-comp command that's useful to determine relationships between version numbers, because Arch has a very specific definition of what makes up a version, because you have things like an epoch, which is the number here before the colon, as well as a package revision. So in this case, even though the actual upstream version is 1.0, this would, if you were to run this through, this would actually be newer than that one, because the epoch is higher than the epoch on the second one, even though the version number is technically newer. And then you have packtree, which is able to list all dependencies of the packages, or all packages that depend on it. So, so these are known as reverse dependencies. So if you're updating a library, you can get a list of things that that's going to be broken once you push that, so you can know what files you need to also build after that. And then Pacman itself also includes a bunch of other tools that's useful to both users and developers alike. So if I can to the screen here. So a quick glimpse here. Inside here, there's the PKG build file that's for this package. This is as well as two files for two Vim files for configuration, as well as a Pacman hook. The main one we're going to look at is here. And so some key things to point out is this is a split package. So this is, when this gets ran, it's going to build out a Vim, a gvim or a graphical Vim, and a Vim runtime package. Because of this, you need to specify a package base, which is used for reports. And then you have the version definitions, a couple of things, so you can define the upstream URL, the license, and then there's 3 levels of dependencies that you have. So you have depends, which are things that the program depends on at runtime to actually work. You have make depends like this, which just needs to be there to build it, but is fine to be missing when running it. And then you have opt depends, which are things that add additional features if present, but is fine to be missing. So you have a list of sources. So they can be locally present files like the vimrc, the archlinux.vim or vimdoc.hook, or they can be files that have to get pulled, that make package has to pull remotely, and this can be via an HTTP, HTTPS, FTP, or a supported version control like Git, Mercurial, or anything like that. And then you have your checksums. So after that, the main things are the functions. So the main ones that have to exist is you have to have a build function that tells it how to build the file or how to build the program. And then you need to have a package, or in the case of split packages, you have to have a package underscore and then package name. So here you have a package underscore vim runtime and a package underscore vim etc. And then there's optional ones that it knows to run, like a prepare, where you can apply patches or make some changes to things, or anything that you need to do beforehand, as well as a check function that allows you to run a provided test suite. So that's a look at how it works inside Arch Linux. So what about the other side, porch trees? So porch trees are made up of categories. So you would have an audio or game, security, lang, which is actually programming languages, not actual people languages. And then you have a devel category, which is development libraries and things like that. And then you have your actual languages like German, Japanese, or Korean. And then dub for things web-based, or X11 for Xorg and its dependencies. And then like the ABS, each category has a directory for each port. So inside multimedia, there'll be like VLC, Firefox is under www, NeoVim is under editors, or Wayland is under graphics. Each port must include a make file, and then there's also the distinfo file, which includes various information. So this is where they stick the upstream URL and basic description about the program. And then there's, oh, no, sorry, that's the PKG descript. The distinfo is where this file size is. So when it downloads the source, it'll record the file size of what it's downloaded and the computed checksum there. And then the PKG descript is where that is. And then you have PKG plist, which is a list of installed files. But it may also include any necessary patches under a subdirectory called files. So some things that the porch tree does is inside the make file, it tells the BSDs configure and make script how to make the port, and this includes being able to use GNU's configure to generate a make file, and or swapping out for the GNU's make instead of BSD make, because some programs depend on the way GNU's configure make works instead of how the BSDs work. So it's able to swap out on demand. And as I said, the disinfo stores the checksum and sizes. And then you have the installed list under plist, which is good for, so another package can't clobber something. So if you try to install another package and it removes a file owned by something else, it will complain about it and won't let that happen. So if we look at a porch tree example, so here we have a couple patches, a make file, which is what we'll be looking at. So this is considerably more verbose than the shell script is, but it's effectively doing the same thing. So you define the version, you define the license, and then the dependencies it actually depends on is spread throughout. So the languages you would build with, and then the options users can choose. So when they run configure, they have they're presented with a list of options that they can enable, disable. So they can enable GTK2 or GTK3 if they were building for GUI them, things like that. And then you have the pre-configure and post-install and things like that. So we find this a lot harder to actually look at and read than the PKG build files, which is why we opted for going that way. So the things that we do to manage this and actually create the hybrid approach. So we match with the FreeBSD ports versions for programs. For the most part, this matches with what Arch Linux ships, so it usually doesn't matter. But some things do lag behind. Usually, the display server and graphics drivers due to lack of support from hardware manufacturers. But there is an effort to fix this called DRM Next, and this will bring up FreeBSD's DRM support to match the current Linux kernel support, and this will let us offer the latest Intel driver and the AMD GPU driver that's been recently released, allowing us to support recent AMD cards as well. So another thing we do is we automatically apply those port patches under those file directories that need to happen during the build process, but not all of them are relevant, so we have to kind of cherry pick through them. And there's some other options in the ports that we want to keep, like the ability to use the GNU configure or gmake, things like that. So one of the ways we do that is we actually patch Pacman and make PKG, adding a couple of options that are relevant to us. Some of them is like the FreeBSD 10 fix, which unescapes certain characters, like this. So in a FreeBSD make file, you'll have this string here, and we want it to look like that. So we'll go ahead and convert that. We want things to be built with Clang by default if it uses C or C++. So we have a set compiler Clang option. And then we have an apply patches that will look for a directory called files and applies any patches it finds in there. And then we have a path fix and path fix 32, which replaces some path placeholders with an actual path to directories. Some optional ones is libtoolfix, which replaces a file called libtool.mk that's some build chains actually use. We replace the one supplied by the vendor with our own, which allows us to build with the correct configuration. Some things we need to build with GCC, so we have an option where we can use that instead. We have an option to convert DOS line endings to Unix line endings. Some files actually use DOS line endings for whatever reason. We have an iConvert, which is able to convert code sets, so it's able to do character encoding changes. So if a file is in UTF-16, we're able to convert it to UTF-8 or Latin 1 just by setting this flag. And then, of course, the GNU configure, which will tell it to use the GNU configure instead of the BSD. So a quick look at what ours looks like. It'll be very similar to the Arch Linux. I'll really only point out the differences. The first one is this line here, which tells, let's see if I can zoom in. It's not zooming for whatever reason. Get to it. Yep. Lost. Yep, there we go. Yeah, the keyboard shortcut was zooming this screen, so now that screen's completely foobarred. So, all right. So the line 1, this pound ports tells our version check script and a couple other things, where in the ports trees to look for things. So in our source repositories, there's a read-only checkout of this Git repository that has a nightly cron job that fetches the latest version of this repository and the latest version of the ports tree, and it will run through here, grab these lines, and will compare our version numbers to the FreeBSD's ones and report any of the packages that are out of date to that. So it will use that. And a couple of other of our scripts use that for being able to grab files or those patches out of the ports trees as well. It uses that to determine where to grab them from. And so we have that. And then the rest of this is pretty much the same. We have the same option set. We have the same sources. So there is one difference in here. We do make a couple other changes in there if you actually want to nitpick, but for the most part, that's the same, but a more interesting one where we actually have to do more work is if we look at bash. So here we have a directory for those patches. So there's a couple of them that gets applied during the build. And if we look at the file here, so again, we have the ports file there. And then here we set our iConverts, our path fix, and we tell it to use the GNU configure. Makes sense. GNU bash would want to be configured with GNU configure. We have to tell our apply patch where, because when we extract it, it doesn't get extracted in a default of package name dash version number. So we have to change it to where it's package name dash base version, which is the 4.4, because otherwise it would be the 4.4.12, which would be incorrect. And then because of the way bash actually ships, we have to go and fetch a bunch of patches every time we build it that gets applied to actually update it. And then here we have to use the GNU make to actually build instead of using BSD make. Another thing we have is a custom tool called PacBuild, which is a wrapper around make PKG in a flexible manner that it supports both using ZFS and UFS, as well as jails and CH roots configurations. So it does different things depending on how it's what you're using and how it's configured. So it also handles creating the base jail or CH root environment for each supported architecture that we have. And it allows us to build a clean package every time. So when we do a build, we build it in an environment that's effectively a clean install of our operating system. So for ZFS, if you're using jails, it creates a data set for the base jail, but it also create an additional data set that sits on top of it that will contain the changes made during the build process. And for CH roots, we just create a snapshot of everything, and then we restore it back to a clean state after building. And then for UFS, since it's a more traditional file system, we basically just have to recreate the environment. There's some common tasks that it does regardless of how it's configured. So it uses nullfs to mount the pacman cache, so where pacman stores the compiled package inside the build jail. So a nullfs is similar to a bind, and where you can mount a directory to somewhere else. And so we do this so that if you've already downloaded a version of a package, it can just use the one that's already in the cache. So save having to download multiple copies of the same package multiple times, speed things up a little bit, and also save hitting the servers just constantly. We create a builder, user, and group inside the base system to allow the build process to work as a non-privileged user. And then it also creates updates and removes these build environments. So the update process allows it to run effectively the pacman SYU to download and install any updates that needs to be done, make sure the key rings are updated, and a few other tasks. And then it's also possible to get shell access to the jail or the CH root through here. So if the build fails and the tool chain writes out a log, you can inspect that log easily. So if you were using a jail and ZFS environment, as I said, it creates a base jail and a data set for each supported Arch. Creates an additional data set for each snapshot for each package being built that sits on top. So when dependencies are downloaded, those actually are written to that additional data set. It doesn't touch the base jail data set. And so if, say, the build fails and you have to rebuild it, there's a couple options that are available. You can start from scratch. This means that second data set will get basically recreated. We restore it from the snapshot, so it's a fresh state. Or you can skip that step, and so if you didn't change dependencies, you can just keep those dependencies installed, skip having to worry about that, and continue on. So it's useful. So if, say, you had to remove dependencies or something like that, you can just start from scratch so those don't exist, so you don't have to worry about anything like that, having additional files in there or anything. Or if you just had a wrong version of something, you can basically scrap the whole thing, make sure that you have the right version by basically updating your pacman cache and then moving on. So because of PacBuild does not know that when you're done with these data sets and snapshots, it requires that you manually have to clean them up. Otherwise, you'll end up with a long list of data sets and snapshots. And over time, this will actually degrade ZFS's performance. So you just need to make sure that you delete them. We have an easy way to do that as well. This is, due to its speed and flexibility, though, this is our preferred method. And then you also have chroots. Chroots work similarly, except we do snapshots and rely on them a little bit more. The main difference is we have a we just have the snapshots. The additional data set is only stores the stuff created during the build process. So we also have to restore the snapshot for the base system. And so it requires a little bit more work on ZFS side, but other than that, it's similar. Again, requires manual cleanup, but it still works. And it's a fallback in case you don't want to use jails or can't use jails for whatever reason. And then regardless of chroots or jails, if you're using UFS, the main thing there is we have to recreate the base environment every time. So we have to do a fresh install constantly. And so this means we wipe out the jail or chroot, reinstall the operating system, and then allow you to rebuild. You can skip the reinstall process if you need to. So if you're just redoing the build process and don't need to worry about reinstalling dependencies. Because of this, though, it's much slower because you don't have the snapshots to restore from. But it is available for users where ZFS is not an option. Or you may not be familiar with how ZFS works, and you just want a more traditional file system. And that's all. Any questions?
It's just a weird offbeat question, but I saw in one of the files that there was a Uganda license. What's the Uganda license? I've never heard of that.
So the Uganda license, that would be one of the Vim files. Let me see if I can quickly find that. But yeah, it's basically a custom file that Vim, or custom license Vim uses. It's kind of makes Vim an interesting dual licensed. It's technically an open source, but they want you to donate to a Help Uganda campaign. You've never opened up Vim and done Help Uganda? You're a horrible person. Just kidding. But no, it's something Bram has been doing ever since he created Vim. It's been there since basically the beginning of Vim. It's a foundation that he heavily supports, and so he's been doing it through Vim, effectively helping promote that foundation. So. So as far as a Vim versus Emacs war, I would have to say, being a Vim user myself, yes, Vim is better than Emacs.
So the only Vim command I know is :WQ. How exactly do you help Uganda through Vim?
First of all, you're better than the millions of Stack Overflow people that have to ask how to exit Vim. But other than that, I missed the rest of the question.
how does the help Uganda command actually work?
So when you actually run it, it uses Vim's built-in help text system. So it'll bring up basically a help page about the foundation, and basically giving you information about that foundation itself and where you can go to donate effectively. So.